For today, we will learn how to calculate the cross product using the determinant method. So first, as we see, we have these two vectors A and B. So in order to get the cross product, first we need to create a matrix. So on the first row of the matrix, we simply arrange the term I, J, and K. So here, we input the second row, which is the values of the A vector. So we have 1, 2, and 3. And for the vector B, simply input it on the third row, -2, 1, 1. So here, in order to calculate the cross product, first we have to focus on the I hat. So for the I hat, in getting the I hat, we simply negate the existence of the first row and the first column. So we simply have I and then negate the first row and the first column. So we have 2, 3, 1, and 1. Next is the J hat. So in terms of the J, we simply need to make it negative, as the values of this term has to be positive, negative, positive. So here, to get the J, we simply negate the first row and the second column. So we can see here, J is positioned here. So we need to negate that column. So what we have is 1, 3, and -2, and 1. The same goes to the vector K, which is negate the third row, the third column, and the first row. So we have 1, 2, and -2, and 1. So here, we simply multiply them diagonally. So for I, we multiply this one, 2, and 1. We multiply them diagonally. So we have 2 minus the product of this second one, which is 3 and 1. So 3 times 1 is 3. So there we have those values. And for J, simply have this. 1 times 1 is equals to 1 minus the product of these two values, the -2 and 3, which is 6, -6. While for the K, which has the values of 1 times the negative times 2 and -2. So we have minus the multiplication of these two values, which is -4. There, we simply calculate them. So we have -I hat minus, which is 1 plus 6 will be 7, so still negative 7j. And for the value of k, we simply have 1 minus negative 4, so in which we get 1 plus 4, so 5, so we get 5k. So there, we simply have this value of the vector, which is negative 1, negative 7, and 5. So there we go. That's how we can solve cross product by using determinant method.
For today, we will find the area of a parallelogram using cross product. Let's say we have a parallelogram that has an adjacent side of u, vector u, and vector v. The area of a parallelogram is the base times the height. We can denote as the height as we can denote height as the y component or of our vector v. This will be our height. So the area of a parallelogram can be written as vector u and the cross product of u and v, and finding its magnitude. So we have a problem. Find the area of the parallelogram with adjacent sides u 2i plus j and v equals negative I plus 2j minus 2k. To answer the problem, we can write u as 2, 1, and 0, and v as negative 1, 2, negative 2. First, we should find the cross product between u and v by using the method taught earlier. So, by finding the cross product of u and v, we find 2i plus 4j plus 5k. We can also write this as a vector 2, 4, 5. Now finding the magnitude of u and the cross product of it to v by using this formula. Square root of negative 2 squared plus 4 squared plus 5 squared. We have the answer of 3 square root of 5 unit squared.